Hello, so today I want to talk about mechanics. Now, in mechanics, we have three quantities which are displacement, velocity, and acceleration. And we're going to proceed to look at how they relate to each other. So, I'd like to start by asking you, what is the definition of these three different quantities? So, uh, I proceed to tell you, which is for displacement, which is a distance moved in a particular direction. Yeah? So notice the difference between distance and displacement. That displacement is now a vector, it has a direction. And velocity. So what is velocity? So velocity is the rate of change of displacement. So it's how fast that displacement is changing. And we know when something changes with respect to time, we can actually relate that in the differential. But we'll go back to that later on. Now, what's the relationship between acceleration and velocity? Now, it's quite similar. The relationship between acceleration and velocity is the relationship between velocity and displacement, which is acceleration is the rate of change of velocity. So let's share a whiteboard and look at this a bit further. So now we have displacement, which we normally mark as S or X. So displacement, which is x, which is the distance moved in a particular direction. Then we have velocity, which we normally call v, which is how fast this x is changing with respect to time. So we can say small change in x over the change in time. And then we can talk about acceleration, which will be how fast this velocity is changing, which will be the change in velocity over change in time. Yeah? Or if it's in a physics definition, we'll say the rate of change of velocity. Yeah. So now we can relate this to our knowledge of small changes or differential changes to actually form a differential relationship. So this means that v is, if this change in x, we want to find the exact velocity at an instantaneous point, then we can reduce this x to a very small quantity, which we know in maths, which we call as dx. And we can reduce this t in the same way, which would be dt. So if we have a function of x, we can find the velocity at any instant using the relationship dx over dt. And in the same way, acceleration is going to be equal to dv over dt. So let's represent this graphically. So let's say that our acceleration, or let's start with displacement. So let's say we have a displacement on the t on the x-axis and displacement on the y-axis. So let's say our displacement is gradually increasing at a constant rate. Yeah, and we know that if our displacement is changing at a constant rate, which means let's say every 1 second we are moving 5 meters, and if we're moving 5 meters every 1 second, then we know by definition that means that we're moving at a constant speed. And if it's in the same direction as we've defined displacement, then that would mean that we were moving at a constant velocity of a certain amount, so which is 5 meters per second. And that is simply the gradient, because we know dx over dt, which is change in y over change in x. If I just make that a bit neater. Change in y over change in x, which is clearly the gradient of this line. You can see the gradient of this line is constant. So in the same way, that acceleration would now actually just be 0. So we'll just have to go like that. Yeah. So acceleration now equals 0 because we have a constant gradient. So our gradient is 0. Our gradient is 0 because there's no change in s over t. So a very simple example where we're moving at constant acceleration. We can also proceed to look in the reverse. So in the sense that if we're looking at the relationship of, so this should be v. If we're looking at the relationship between the velocity and the acceleration, we can say that the velocity is the integral of acceleration. So if we integrate both sides here, we'll separate the variables. As we know in pure, where we learn in pure maths, a dt will equal to dv. And if we integrate both sides, then we can find out that v equals to the integral of a dt. Yeah. Here we have 0 acceleration, so we just left our a is 0, so this would just be a constant. The integral of 0 is actually a constant, so that's the constant that we are left with here. And then in the same way that we rearrange this equation, we can also get x as the integral of velocity, and that would give us okay. So if we proceed, it won't give us a constant. So now we have we're integrating a constant. So we have v equals dx over dt. So we're integrating a constant. So we know v is a constant. So let's say we started with value 5. Now that will become 5x. And of course, if we draw a graph of 5x or 5t, x equals 5t, then that would give us this graph here with a constant gradient of 5. Yeah. And if we had more time, we could look at different examples, but this shows how our acceleration, velocity, and displacement are all interconnected and related to each other. Thank you for listening.